one of the ways that we can actually talk about, circuits is we can control them. All right? And controlling circuits is quite important because you don't always, in a machine, you don't always want your circuit operating. Okay? You want your circuit to actually be able to power down every once in a while when you're not using it. Because otherwise you will use, if it's a battery, okay, depending on what your power source is, and we'll get to that, you will use your power source up. Okay, for no reason if the machine is just sitting idle. So what we've done is we've actually developed something called a switch. Okay, and switches are embedded in all electrical engineering circuits. There's an on button, basically, or an on flick or a knob that you can turn, and it will actually close the circuit. Now here's where it gets a little confusing. Okay, by closing the circuit, so a switch is usually drawn like so. And this are made of metal, okay, so that when the actual switch ends up, so in this case, the switch itself is open, correct? Now, is the circuit actually working when the switch is open? No, the circuit is off. When the switch is open, the circuit is off. Because the switch being open creates a break in the loop of the wiring. Okay? The other way to actually draw this, right here, okay, exact same circuit right here. Here's my light bulb. Now you'll notice how there's no actual gap right here. The switch is closed. When the switch is closed, the circuit is operating because the loop is complete. Okay? So when we want to talk about controlling circuits, we're talking about switches. And most often you will have a machine that, maybe something falls into place and it lands on the actual button and it turns on the circuit. Case in point, the ball launcher that we looked at with the dog. Okay, the ball would actually, get dropped down a ramp, and then there was a knob here, and below it was actually your switch for the circuit, and it would basically turn it on, and it would cause the ball that landed on it, that would push it down, to then get flinged off to the side. Okay, because of the arm that would actually move because of the electrical circuit, and it would whack the ball out of place. And as soon as the ball was gone here, okay, as soon as there was no more weight, the circuit, basically the switch opened up, right? So the circuit shut down, so we weren't wasting power. So when we're talking about controlling circuits, okay, we're talking about including a switch in the actual circuit. Now, we've got a variation of types of switches, but we don't have to worry about those. When we talk about an actual switch, this is what your switch is going to look like. Okay? Open versus closed. When you have an open switch, the circuit is not linked. There's a breach in the loop. So if there's a breach, no actual electrons are being moved around. Therefore, whatever resistor is there gets turned off. Nothing happens. Okay?